Hi everyone. Hope you all are good. Okay, hi everyone. Hope you all are good. We are here for grade 10 math. So you can find all the lessons on aplusstudents.com. You have to log in there using your email address and password as provided by the administrator. Then you have to select math from the subject tab. Scroll down to grade 10 and then click on view all lessons. So there you can find a list of the chapters. We're going to start with the chapter algebra. The lessons we are going to cover today are ratios and proportions, scale drawings, word problems, and properties of exponents, right? So we're going to start with the very first lesson, that is ratios and proportions. So please make sure you have your notebook and pencil so that you can note down the important examples and definitions as well, right? Okay, so basically we are given the ratios, right? We have to see if they form a proportion. For example, you are given two ratios 11 over 10 and 8 over 5. You have to see if both the ratios form a proportion. So what we have to do whenever we have to determine whether the two ratios form a proportion, you can compare them using a common denominator, right? First of all, you have to make their denominator common, right? This is 11 over 10, this is 8 over 5. You have to make this denominator equal to 10. Let's just multiply 5 times 2 makes 10. Let's just multiply this fraction by 2, right? That would be 8 times 2 divided by 5 times 2. So that would be 16 over 10, right? So the other ratio is 11 over 10 and 16 over 10. You can see now that is 11 over 10 and 16 over 10. They have same denominators, but their numerators are still different. So the ratios do not have same value, right? That means the ratios 11 over 10 and 8 over 5 are 8 over 5 do not form a proportion, right? Let's just do another example. Okay, you are given the ratios that are 8 over 14 and 4 over 7. You have to see if they form a proportion, right? Let's just make their denominators same. Here you have 7, here you have 14. You have to multiply this fraction by 2 to make it their denominator same, right? So it is 8 over 14. That would be 4 over 2 times 7 times 2. So when you multiply it by 2, it would be 8 over 14. So just compare this one and this one. They have same numerators and same denominators, right? That means these two fractions, these two ratios form a proportion, right? So let's just go to the lesson ratios and proportions on A plus. Let's just do the practice questions from more practice questions from the lesson, right? Okay. Here I'm on grade 10 math. The chapter we're working on is algebra. Let's just start with the lesson ratios and proportion. Let's just start with the test questions, right? Okay, do the ratios 11 over 10 and 8 over 5 form a proportion? So we just did examples. How do we know? We have to make their denominators same, right? Okay, that is 11 over 10 and 8 over 5. Let's just make the denominators of both the fractions same. Here you have 5. 5 times 2 makes 10. You have to multiply this fraction by 2. That would be 11 over 10. And here you have to do 8 times 2 divided by 5 times 2. So when you multiply this fraction by 2, it is 16 over 10. Right? So just look at the both the fractions. They have same denominators, but still different numerators, right? That means they do not form a proportion. Both the fractions do not form a proportion, right? The answer is no. Okay, do the ratios 19 by 20 and 2 by 4 form a proportion? Okay, 19 by 20 and 2 by 4. I think no. I'm sure no. 19 by 20 and 2 by 4, right? Let's just make their denominators same. You have to multiply this fraction by 5. That would be 2 by 5 and 4 by 5. So when you multiply by 2, it would be 10 over 20. Still, they have different numerators, right? If they have, when making their numerators same, if you if their numerators are also same, they are the ratios form the proportion, right? But here, still they have different numerators. That means they do not form a proportion, right? That means they do not form a proportion. The answer is no. Okay, the next one is, do the ratios 1 by 2 and 5 by 10 form a proportion? Let's just make their denominators same, right? So 2 times 5 makes 10. You have to multiply this fraction by 5. So it is 5 by 10. 1 times 5 and 2 times 5. So that would be 5 over 10. See, both the fractions have exactly same numerator and same denominator, right? That means 5 by 10 and 1 by 2 form a proportion, right? Both the fractions form a proportion, right? The correct option is yes, they form a proportion. Okay, do the ratios form a proportion? Do the ratios 1 by 12 and 1 by 3 form a proportion? You can solve this question in your notebook. Just write down the answer in the chat box if yes or no. The correct option is yes, the correct option is yes, they form a proportion. The correct option is yes. Do the ratios 1 by 2 and 8 by 16 form a proportion? Which is the correct option? The correct option is yes, they form a proportion. The correct option is yes. Very good. Okay, do the ratios 1 by 20 and 3 by 4 form a proportion? Which is the correct option? The correct option is no, they do not form a proportion. The correct option is no. Do the ratios 13 by 10 and 4 by 2 form a proportion? Which is the correct option? The correct option is no, they do not form a proportion, right? Very good. That would be no. Do the ratios 4 by 3 and 20 by 15 form a proportion? Which is the correct option? The correct option is no, they do not form a proportion. Oh, yes, they form a proportion. 5 times 4 is 20 and 3 is 15. Yes, they form a proportion. Do the ratios 15 by 10 and 3 by 2 form a proportion? Yes or no? The correct option is yes, they form a proportion. Do the ratios 10 by 20 and 1 by 2 form a proportion? Yes or no? Which is the correct option? Yes, they form a proportion, right? Okay, you can complete the lesson by yourself later today. Let's just start with the next lesson. The next lesson is, I think, scale drawings, right? So, what is scale drawings? What does scale drawings mean? So, basically, a scale drawing is an enlargement of an object, right? An enlargement. of an object. So, scale drawing is a drawing that shows a real object with accurate size reduced or enlarged by a certain amount, right? Okay, so let's just do some of the examples from the scale drawings, right? Okay, let's start with an example. Hold on. Okay, so let's start with an example. Okay, so let's start with the example. So the example is, okay, let's just do example from A plus because I am unable to find the examples right now. So let's just do the examples from A plus. Okay. Bella drew a scale drawing of a summer camp. The sand volleyball court is 8 millimeter long in the drawing. The actual volleyball court is 16 meters long. What is the scale of drawing? So basically, when in the drawing, the volleyball court is 8 millimeter long, but actually it is 16 meters, right? So you have to see, you have to basically find what scale she have used, right? How do you find the scale? Form a proportion between the drawing to the length of the actual value. The drawing is 8 millimeter long, right? And original value is 16. So it is 8 millimeter divided by the 16 meter, right? Just simplify this fraction. It would be 1 millimeter divided by 2 meter. That means the scale of the drawing is 1 millimeter equals 2 meter in the drawing, right? So 1 millimeter equal 2 meter. What you have to do, you just have to form a proportion between the scaled and the original value, right? The actual value. Let's just do other example. Kayla drew a scale drawing of a house and its lot. She used the scale 1 inch equal 4 feet. You are given the scale, right? 1 inch equal 4 feet. If the actual length of the house is 24 feet, so the actual length you are given is 24 feet, right? How long is the driveway in drawing? You have to calculate the value in drawing. We know that 1 inch equal 4 feet, right? That is the scale, 1 inch equal 4 feet. So this one is 24. So that means you have, when you multiply 1 times 6, you have to make their denominator same. 1 times 6 and 4 times 6, that makes 6 over 24. That means if it's in drawing it is 24 feet. If originally it is 24 feet, in drawings it must be 66 inches, right? Let's just start with the practice questions. In Beverly Hills, the Hollywood actors own houses that are 4 kilometers apart. How far apart the actors' houses on the map with a scale of 2 centimeter to 1 kilometer? You are given the scale that is 2 centimeter to 1 kilometer, right? The scale is 2 centimeter to 1 kilometer, right? You are given the two Hollywood actors own houses that are 4 kilometers apart. So the original value is 4 kilometer, right? Here you have 4 kilometer. You have to calculate this value. So let's just make the denominator 1 times 4 is 4. You have to multiply this by 4. It would be 4 times 1 is 4 and 4 times 2 is 8 centimeter. That means it is then originally distance is 4 kilometers. In drawing, it is 8 centimeters. So the correct option is 8 centimeters. So it is 8 centimeters. The correct option is 8 centimeters, right? The original distance is 4 kilometer. The in drawing that would be 8 centimeter, right? Okay, Brandon drew a scale drawing of a house, the garage, which is 14 meters long in real life, is 35 centimeters long in the drawing. What scale did Brandon use, right? So originally it is 14 meters and drawing it is 35 centimeters. So you have to see what scale you have used. So what you have to do, you have to form a proportion, right? Proportion between the scale value and the original value. The scale value is 35 and the original value is 1435. Let me just write down there. 35 centimeters and 14 meters, right? And here you are given 5 centimeters equal how many meters, right? You have 5 centimeter to meters, right? You have to calculate this value. 35 divided by what number equals 5? Just simplify this one, right? 7 times 5 is 35 and 7 times 2 is 14. That means it is then 5 centimeter to 2 meter, right? That means 2 meter equal 5 centimeter. That is the scale she have used, right? So the correct option is 2 meters, right? Kela drew a scale drawing of a house and its lot. He used a scale 1 inch equal 4 feet. If the actual length of the house driveway if the actual length of the house driveway is 24 feet, how long is the driveway in the drawing, right? The scale is 1 inch to 4 feet, right? You are given the scale. You are given the scale that is 1 inch to 4 feet, right? So the actual length of the house is 24 feet. You have to calculate the value in the scale drawing, right? Let's just make the denominator same. 4 times 6 makes 24. Just multiply this 1 by 6. So it is 1 by 6 equals 4 times 6. So 1 times 6 is 6 inches and 4 times 6 is 24 feet. That means if originally it is 24 feet, in drawing it will be 6 inches. The correct option is 6 inches. Dustin is an election officer. On election day, he travels to the polling place, which is 64 kilometers apart from his house. On a map of Richmond country, these two places are 2 centimeters apart. What is the scale of the map? Right? That means the actual distance is 64 kilometer, right? But on the map, it is 2 centimeter apart. So just form a ratio between the scale drawing and the origin actual one, that is 2 centimeter divided by 64. And you are given the scale, that is 1 centimeter equals how many kilometer? Just simplify this fraction, right? You have to divide by a common factor, that would be 2 times 1 is 2 and 2 times 32 is 64. That means then 1 centimeter equals 32 kilometers, right? So it is 1 centimeter equals 2 kilometer 36 kilometers in the, sorry, 1 centimeter equals 32 kilometers in the drawing, right? 32 is the correct option. Jonathan made a scale drawing of a house and its lot. He used the scale 1 centimeter equals 6 meter. In the drawing, the back patio is 2 centimeter wide. What is the width of the actual patio, right? The scale is 1 centimeter to 6 meter. Okay. So the patio is 2 centimeter wide. Actually, it is 2 centimeter wide. You have to see drawing, right? So 1 times 2 is 2, and you have to multiply 6 times 2, right? So 6 times 2 is 12. That means 2 centimeter equal 12 meters. That would be 12, right? The correct option is 12. Okay, you can complete the lesson by yourself later today. Let me just move on to next lesson, and the next lesson is properties of exponents, I think. Yes. The next lesson is properties of exponents. Let's just see what are the exponent and what are their properties, right? Okay. So, okay. So basically, we can write the lesson we are working on is properties of exponents. We can write exponents like this. For example, you have x and n, right? X is the base and n is the exponent, right? Okay, so x is the base and n is the exponent. Okay, let's just discuss some of the properties of exponents, right? Okay, so the first one is the product rule. First one is the product rule. That means if they have same base, right? Like you have two am and an. You can see for the both the exponents they have exactly same base, right? So when they have same base, what you have to do? You simply have to add their exponents, right? It would be then a m plus n. So for example, you have x exponent 2 and x exponent 3. You have to do x exponent 5, right? The other one is the quotient rule. The quotient rule is if you are dividing with the same base, am divided by an, right? They have same base, a is the base. You have to subtract their exponents, right? The example is you have x9 divided by x5. You have to do x9 minus 5 and the answer is x exponent 4. Got it? The next one is power rule. Power rule 1, right? That is a exponent m and the exponent n. Is in if you have something like this, you have to a m times and you have to multiply both the exponents, right? For example, you have x exponent 3 exponent 4, so you have to do x 3 times 4, so it would be x exponent 12, right? Then you have power rule 2. Power rule 2 is if you have something like this, ab exponent m, right? You can write them like this, am and an. Basically m is the exponent of both a and b, right? For example, you have 4x cubed 2, right? So 2 is the exponent of 4 also, and like this also, right? So it would be 16 and x exponent 6. Then you have negative exponent rule. If you have a exponent negative m, you can write them as a exponent m. The example is you have x negative 2, you can write it as 1 over x square. Basically, when you reciprocal the value, the exponent would be then positive. And if it is like this, a over 1 over a minus m, you can write it as am, right? Then you have zero exponent. Like any base that have the exponent 0 equals 1, right? These are the sum of the properties of the exponents, right? Now we're going to do the practice questions where we are going to apply these properties. Let's just start with the practice questions. Here it is, properties of exponents. You have to apply these properties, right? Okay. Simplify. M exponent negative 9, exponent negative 3. So that is the power rule, right? Whenever you have the exponents like this, you have to multiply both the exponents, right? So you have to do negative 3 times negative 9, that would be positive 27. So option number So it is m exponent 27. Option number 1 is the correct option, right? The second one is r exponent 8 times negative 9. So again, you have to apply the power rule here. You have to multiply both the exponents. So 8 times negative 9 is negative 9 times 8 is negative 72, right? So option number 2 is the correct option. Very good. Okay, simplify. Express your answer using a single exponent, right? So you have to multiply both the exponents, negative 7 times negative 6, right? So 7 times 6 is 42. Both the numbers are negative. So answer must be positive. So it would be D exponent 42. So option number 2 is the correct option, right? Okay, simplify. Which is the correct option? Yes, very good. That would be option number 1. Negative 5 times 7 is negative 35. Okay, which is the correct option? M exponent 3 exponent 4. Which is the correct option? You have to multiply both the exponents, right? 3 times 4 is 12. So it is M exponent 12, right? Option 1 is the write the expression as a variable with a negative exponent, right? That is the negative exponent rule you have to apply here, right? It would be 1 over a2. So when you move it to the numerator, it would have a negative exponent. So second one is the correct option. Simplify. Which is the correct option? Yes, 3 times negative 2 is positive 6. So option number 1 is the correct option. G exponent 6. Simplify. Which is the correct option? All of them have exactly same base, right? You have to add them. 3 minus 9 is negative 6 and negative 6 plus 4 is negative 2. So the second option is the correct one. Write the expression as a fraction with a positive exponent. So how do you make the exponent positive? By taking the reciprocal, right? So it would be then 1 over g exponent 7. The second option is the first one is the correct option. Simplify. How do you simplify? For the one y exponent 4 and y exponent negative 5, they are multiplying, right? You have to apply the product rule over here, right? So when you apply the product rule, their exponents got added. 4 minus 5 is negative 1. You have y exponent negative 1 in the numerator. And for the denominator, you have to apply the quotient rule. For the numerator, it would be y exponent 4 minus 5, right? 4 minus 5 is negative 1 over y exponent negative 3. For the denominator, you have to apply the quotient rule. It would be y negative 1 minus 3. So it would be y negative 1 plus 3. 3 minus 1 is 2, so it would be y square. Option number 1 is the correct option, right? Okay, we are done with the lesson. So we were working on grade 10 math. The lessons we are working, the lesson we have completed today are, we're working on grade 10 math. Chapter we're working on is algebra. Review the lessons we have covered today are ratios and proportions, scale drawings, word problems, and properties of exponents. So please make sure before the next session you can complete all the practice questions for the lessons we did today. That's your homework, right? So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9, right? So that's all for today. If you have any question, you can please ask.